Welcome to our review of Unit 4, Firm Production, Businesses and the Costs of Production. First thing we'll take a look at are economic costs. These are the costs that have to be made to obtain or retain the services of a resource. Accountants would look only at explicit costs. This is the money that you put out to start the business. Economists, on the other hand, take into account implicit costs. These are the costs of the opportunity for using self-owned resources, the value of their next best use, as well as a normal profit. Accounting profit takes into account total revenue minus explicit costs. So accountants only look at our monetary outlay. Economists, on the other hand, are going to look at our accounting profit minus the implicit costs. Remember, our implicit costs are those things that those resources we could have used elsewhere. So we have to take into account money maybe that we would have earned if we had worked a regular job as opposed to starting our own business. We have to take into account interest that we've given up by taking money out of the bank. So in order to find economic profit, we're going to take a look at revenue minus economic costs. So if we spread that all out, it's revenue minus explicit costs minus implicit costs. Here we have a visual of economic versus accounting profit. On the left, we'll see economic profit or economic costs. So we take into account the explicit costs, the implicit costs, and at the top we have our economic profit. We include the normal profit, which is a profit that we assume that a company will earn to stay in business. Anything above that normal profit is known as economic profit. And if we remember, that will drive firms to enter the market until that economic profit disappears. If we look on the other side, we see total revenue, which is simply our accounting profit and our accounting costs together. So if we subtract accounting costs from total revenue, we find accounting profit. The next major concept we have to look at is the short run versus the long run. We can think about this in terms of rate versus capacity. In the short run, we have some variable inputs, but we have a fixed plant. So what that means is we basically have a factory that we can't increase the size of. What we can do is we can add variable inputs to that factory to increase the rate that we produce at. So in the short run, we can have increasing and decreasing rates of production. However, the factory itself can't change. In the long run, all inputs are variable. So in the long run, we can actually increase capacity. We can adjust our plant size. We can also decide to enter or exit the industry, as well as hiring more workers, increasing the amount of resources that we use, so on and so forth. Production relationships reflect how labor and output are related in the short run. Total product is the total quantity that is produced. Marginal product, or MP, is the amount that total product changes when labor changes by 1 unit. We can see that mathematically with the equation marginal product equals change in total product divided by change in labor input. Most of the time the change in labor input will be 1, so marginal product generally just equals the change in the total product. The average product is the output that is produced per unit of labor. And we can see that mathematically, average product equals total product divided by units of labor. The law of diminishing returns. In order to understand the law of diminishing returns, we kind of have to take a look at the production function. So we need to understand that if we start with a fixed plant and we begin to hire in more variable units of labor, and labor will be the resource that we're going to talk about in terms of variable resources. So if we have a factory, we hire 1 worker, that worker will increase the total output from 0 to whatever he brings. As we hire the second worker, they will bring even more, total product will increase even more, marginal product will increase as well. We hire a third worker, we see total product increase, marginal product also increases. This is all during the first stage of production. When the second stage of production happens, we start to see the law of diminishing marginal returns take place. Basically what this says is as we hire more variable inputs, we get less and less from each one. So total product stays positive, but marginal product begins to fall. At some point, marginal product will actually become negative. This will be stage 3 of production. Here we can see an example of the law of diminishing marginal returns. In the left column, column 1, we have the units of the variable resource, which is labor. Column 2 is our total product. You can see that that increases as we hire more and more labor. Column 3 is our marginal product. So in order to find that, we simply subtract the first number or the second number in column 1. I'm sorry, the first number in column 1 from the second number. So for our first worker, 10 minus 0 gives us 10. Our second worker, 25 minus 10 gives us a marginal product of 15, and so on. We see that initially we have increasing marginal returns. Then we hire our fourth worker. we end up with diminishing marginal returns. And by the time we get to our 8th worker, we see marginal product actually go negative. Therefore, we have negative marginal returns. The 4th column shows us our average product. And this tells us how much each worker on average is contributing. Here we have the law of diminishing returns shown graphically. The top graph is total product. So we see in the yellow beigeish segment increasing returns. In the green segment we see diminishing returns. And finally in the peach segment we see diminishing returns as total product begins to fall. In the bottom of the two graphs we can see that over time marginal product increases initially at an increasing rate. Then we see that it starts to decrease and finally goes towards the negative when we get to our 7th worker. We can also see this through average product. Average product initially will rise and then will slowly begin to fall. Now let's take a look at our short-run production costs. The first cost we'll look at are fixed costs. Usually we will abbreviate this as TFC, or total fixed costs. These do not vary with output. Fixed costs are things that we have to pay regardless of how much we're actually producing. So it may be taxes, it may be depreciation on capital equipment, it may be salaries to executives. Variable costs are the things that do vary with output. So the more output we create, the more we have to pay for them. So this would be the raw materials that we put in, and it will also be the number of workers that we hire. The more workers we hire, the higher our variable costs go. This is abbreviated as TVC for total variable costs. Our total cost is the sum of our total fixed costs and our total variable costs. Here we see the short-run production costs. The red line is the total fixed cost. At this point it's 100. It's always the same because it's fixed. The light blue line are our total variable costs. These are the costs that increase as production increases. The dark blue line is our total cost. You'll notice that the distance between total cost and total variable cost always remains the same. If you were to subtract that distance at any point along these two curves, you would find that it equaled 100 because that represents our total fixed cost. Now let's take a look at our per unit or average costs. In order to find the average fixed costs, we simply divide total fixed costs by the quantity produced. The average variable cost is the total variable cost divided by quantity. Average total cost is total cost divided by quantity, and our marginal cost is the change in total cost divided by the change in quantity. Most of the time, this will also be done in increments of 1. Therefore, our marginal costs, generally speaking, will be simply the change in total cost. Here we can see a chart that shows us our short-run production costs. This is the production function that I'm sure you all remember from Farmer Joe. Our first column is total product. Our second column is total fixed cost, which is always 100. Our third column is total variable cost, which increases as we hire each worker. Our fourth column is our total cost, which is simply columns 2 and 3 added. Our fifth column is our average fixed cost, which would be 100 divided by quantity in every case. Our sixth column is average variable cost, so it's our total variable cost divided by the quantity. The seventh column is average total cost divided by quantity, and our marginal cost is the change in total cost divided by the change in quantity. Here we can see our costs graphically as well. The green line represents our average fixed costs. You notice that that declines over time. That's because our first unit in terms of fixed costs costs us 100. Our second unit, we divide the fixed costs 100 by 2 and we get 50. Our third unit is at 33 1/3, so on and so forth. Our average variable costs, you will see initially decline and then begin to rise again. This is representative of diminishing returns. And our average total costs, we see starts very high, bottoms out, and then begins to rise with our average variable costs. Here we've added in marginal cost. Remember, our marginal cost is representative of how much it costs us to make each additional unit of the product. You'll notice that marginal cost cuts through the average variable cost and the average total costs at their lowest points. This occurs because when marginal cost is below either average total cost or average variable cost, they will be falling. Once marginal cost is above average variable cost or average total cost, they begin to rise. The marginal cost curve and the average variable cost curve are mirror images of the marginal product and average product curves. Assuming that labor is the only variable input and that its price, the wage rate, is constant, then when marginal product is rising, marginal cost is falling. and when marginal product is falling, marginal cost is rising. Under the same assumptions, when average product is rising, average variable cost is falling, and when average product is falling, average variable cost is rising. Long-run production costs. An industry and the individual firms that are in it can make all desired resource adjustments in the long run. All resources are variable, including plant size. Therefore, all costs are variable in this time period. So in order to find the long-run average total cost curve, we're going to take a look at different short-run average total cost curves. What we have here are a series of average total costs in the short run. This bumpy curve is also called the planning curve. And basically what we'll find is that the long-run cost curve will simply be a smoothing out connecting the low points of each of these average total cost curves in the short run. The long-run cost curve, as you can see, is simply a smoothing out of these average total cost curves in the short run. What you'll see is that over time the firm will reach the bottom of its average total cost curve, and then will seek to expand in order to further lower its average total cost. So what we have is a time period, this is known as economies of scale, where it makes sense for the firm to increase in size to lower its costs. Once they reach the bottom, they'll begin to see diseconomies of scale, whereas the firm grows, their costs actually increase. So if we take a look at what economies of scale are, basically economies of scale can come about for a number of things. As plant size increases, we will see lower unit costs. An increase in inputs where the economies of scale will lead to a more proportionate increase in output. In other words, as workers get better at their job, as managers get better at their job, as they use capital more efficiently, as well as several other factors, firms will be able to produce a product more and more cheaply. Somewhere at the bottom of this, we'll have something known as constant returns to scale. This is where, regardless of the number of inputs that you add, you have exactly this proportionate number of output. Diseconomies of scale occur where costs continue to increase even as the firm expands. This happens because you have control and coordination problems. In other words, you may have a managerial issue. You also have communication problems between management and workers. You may have worker alienation where they feel that they're not really part of the firm because the firm has grown so much. And because the firm is so large, you may end up with a problem with shirking, where people are not actually doing the job that they are hired to do. Minimum efficient scale, or MES, is the lowest level of output at which the long-run average costs are minimized. This can determine the structure of the industry. Where MES occurs on an industry's long-run average total cost curves determines whether there will be many or few producers and whether they will be large, small, or of different sizes. Natural monopoly is a rare situation where economies of scale extend beyond the market size. Therefore, one large firm can provide the product more cheaply than a multi-firm market. Here we have MES and industry structure shown graphically. So long-run average total cost curve showing industries with an extended range of constant returns to scale. That's this flat part here. These industries will be populated by firms of many different sizes. Small and large-scale producers will coexist and be equally successful. MES occurs at an output of Q1. So this is the lowest, the first point where you can have the lowest possible cost for production. Industries with economies of scale over a wide range of outputs will lead to a few large-scale firms. This long-run average total cost curve is lowest only when there is a very large output here. So this would tend to lend itself to a natural monopoly. Here we have a long-run average total cost curve where economies of scales do exist here. They are exhausted very quickly and turn back up substantially. So we see huge diseconomies of scale. Minimum efficient scale occurs in a very small segment of this curve at a low level of output. This results in a large number of small producers. Well, that's it for our Unit 4 review. Please go through this video more than once if possible. It will help you get ready for the exam.